Hello, my dear students. Let us take one more example. If a water course commands an irrigated area of 600 hectares, the intensity of irrigation of rice in this area is 60%. The transplantation of rice takes 12 days and total depth of water required by the crop is 50 centimeter on the field during the transplantation period. During the transplantation period, the useful rain falling on the field is 10 centimeter. Find the duty of irrigation water for the crop on the field during transplantation at the head of the field and also at the head of the distributary, assuming losses of water to be 20% in the water course. Also calculate the discharge required in the water course. Okay, so here you have to calculate the duty of irrigation water for the crop on the field during the transplantation and also at the head of the field and also at the head of the distributary. Okay, what is this transplantation? Transplantation is nothing but to remove a plant from one place and plant it again in some other place. Okay, that is transplantation. So here there are three sub questions are there. You have to calculate that. Okay, so here we know the delta is equal to 8.64 B divided by D. Right, B is transplantation period, that is given here 12 days. Okay, then delta, the depth of irrigation water actually applied in the field. Okay, so this is actually, or you can say that this is the depth of irrigation water actually applied in the field, or you can say the depth of the water required to be supplied by the water course. Okay, so here the water required by the crop is 50 centimeter and during the transplantation period the useful rain falling on the field is 10 centimeters. So water available to the plant is now actually applied in the field is 50 minus 10, that is 40 centimeter. Okay, equal to 0.4 meters. So this is the water actually applied in the field. Now duty of the irrigation of irrigation water on the field is in hectares per cubics. Okay, now we have formula. Duty is equal to 8.64 B divided by delta. So 8.64 into P is 12 days, 12 divided by delta. Delta is equal to 0.4. Okay, so you get 259.5 hectares per cubics. This is the duty on the field. Okay, this is the irrigation water which is available on the field. Okay, that first question is done. This duty of irrigation water for the crop on the field during transplantation, that is equal to 259.5. Now at the head of the field we have to consider, we have to find, and also at the head of the distributary, assuming losses of water to be 20% in the water course. So now here you have to consider there is a loss of 20%. So all of us know 1 cubics of water discharged at the head of the water course will become now 100 minus 20, that is 80%. So means 0.8 cubics at the head of the field. So water available at the head of the field is only 80%. So that is nothing but 0.8. So we'll irrigate, hence it will irrigate only. So what is the duty available at the field is 259.5. in that only 80% of the is available, so that is 259.5 into 0.8, that is equal to 207.6 hectares only. This is the head of the water course, discharged at the head of the water course. Now So that is equal to 207.6 hectares per cumex, because you have considered the losses here. Next, now you have to find the discharge at the head of the water course. How we can calculate? The discharge is nothing but area divided by duty. Here area is given, the total area on the rice plantation is 600 hectares. Okay, the intensity of irrigation of the rice in this area is 60%. So only 60% area is used for the rice plantation. So 600 into 0.6, that is equal to 360 hectares. So discharge at the head of the water course is equal to area divided by duty. Area is 360 hectares divided by this duty. The duty at the head of the water course is 207.6. That is equal to 1.735 cumex. So this is the discharge required in the water course. So like this, you have to calculate the duty of the water on the field during transplantation, and at the duty at the head of the field, and also at the discharge in the water course. I hope all of you understood. We'll take one more example. Table below gives the necessary data about the crop, their duty, and the area under each crop commanded by a canal taking off from a storage reservoir. Taking a time factor for the canal to be 13 divided by 20, calculate the discharge required at the head of the canal. If the capacity factor is 0.8, determine the desired discharge. So you have to calculate the discharge here. Okay. So here it is given, time factor is given and capacity factor is given, and these are the given data which is for the different types of the crops. Base period is given, area is given, duty at the head of the canal is given. So let us calculate first what you have to find. Discharge required for the each crops. So here let us take this first example, that is for the sugar cane. The discharge is equal to now area divided by duty. The discharge is equal to area divided by duty. So for the sugar cane, area is equal to 850 and divided by duty, that is equal to 580. So 850 divided by 580 is equal to 1.465 cumex. Next crop is the overlap for sugar cane, that is hot weather. Okay, so here area is 120. 120 divided by 580. So that is 120 divided by 580 is equal to 0.207 cumex. Next, discharge for wheat, that is rabi season crop, that is 600 divided by 1600. Okay, so that you get 0.375 cumex. Next is bajri, that is equal to 500. This one, bajri, 500 divided by 2000. Okay, so that is 0.25 cumex. Next, discharge for vegetables, that is this 360 divided by 600. Okay, so you get 0.6 cumex. So first step is to calculate the discharge for the each crop. Next, what is given here, since sugarcane has a base period of 320 days, it is given in this sugarcane has 320 days, means almost 1 year. So this crop is required water in all the season, that is at rabi season also, monsoon season also, hot weather also. So now you have to calculate discharge required for each season. Okay, so first let us consider for the rabi season. Discharge in the rabi season means water required in the rabi season. That is rabi season, how many crops are there? Sugarcane you will have to consider because it requires discharge in all the areas. So that is 1.465. In addition to that, what is in the rabi season? Wheat also it's grown in the rabi season. So that discharge also you have to calculate. What is that weight discharge? That is 0.375. So 1.465, this is for sugar cane, plus 0.375, it becomes 1.84 cubics. Okay. Next, discharge required in the monsoon. Monsoon season also this sugar cane requires water because it has a base period of 320 days. So 1.465, that is for sugar cane, plus what is grown in the monsoon season, it is given in the problem, that is bajri. So what is that? Discharge is 0.25. So that also you have to consider. In addition to sugarcane, bajri also you have to consider. That is 1.465 plus 0.25. That is equal to 1.716 cubics. Okay. Next, discharge required in the hot weather. Here also this sugarcane you have to consider. That is 1.465 discharge of sugarcane. And one more is hot weather crop is vegetable. That is what is the discharge required in the vegetable? That is 0.207, because there are two hot weather groups. One is overlap for sugarcane, that is also hot weather. So that and vegetable, both the discharges you have to consider. That is this one overlap sugarcane 0.207 and discharge for vegetable 0.6. So it becomes 2.273. So the maximum demand of the water is 2.273 cubics. Okay. That is in the hot weather. So this is the first step. You have to calculate the discharge required and what is the maximum demand of water, that is during hot season, hot weather. So that is equal to 2.273 cubics. Okay, this is cubics. Next, you have to consider the time factor and the capacity factor. Time factor is nothing but it is the ratio of the number of days the canal has actually run to the number of days the canal was supposed to run. Okay, so it is the number of the days actually run to the supposed to run. So that is given here, 13 divided by 20. It is given in the problem. Now, you have to consider the discharge, a full discharge at the head of the canal. That is nothing but the maximum discharge or water required divided by time factor. Maximum discharge required is 2.273 divided by time factor. Time factor is 13 divided by 20. So, when you consider this, it becomes 2.273 into 20 divided by 30, that is equal to 3.497 cubics. Okay, and capacity factor is given here 0.8. That also consider how the design discharge, that is equal to full supply discharge divided by capacity factor. This is the formula to find design discharge. So full supply discharge, that is 3.497 divided by capacity factor, it is given as 0.8. So 3.497 divided by 0.8, that is equal to 4.372 cubics. So this is the design discharge which is asked in the numerical. Okay, I hope all of you understood. If you have any difficulties with them, we will discuss in the class. Thank you.